All right, cool. Anybody in the front row, if you guys notice it takes a break or something, just let me know. It will take union breaks every now and again. Do this before this guy burns out. All right. So to break this down even further, even though you don't want to, there's 4 main subtypes of data. So you got these 2 main divisions. It sort of feels like phylums and kingdoms and phylums and stuff in biology, but thank God it's not quite. So we just break it down a little bit further. And each level up is an extra level of being able to do something with the data. You'll see what I mean here in a second. The most basic level of data is called nominal. What do you think that has to do with? Oh, there's no. Is it better? More stuff. Hopefully nothing's radioactive. Anybody?
It's like the qualitative?
Yeah, it's like qualitative. The root word of that is nom. Have you ever heard of something called a plume de nom?
Like one thing, one group.
It's not quite like not like a mon. It's nom. I like that though. It's not like monomial. It's nom. Nominal. Nominal. Plume de nom is like a pen name. Some authors' pen name. They don't use their actual name. They use a pen name. So it's names. Nominal is names. For some reason, people suddenly start to think this means number. And I can kind of forgive you, it starts at the end. But nom is name. It's like categorical. So this is name data. So this is basically just like qualitative. Hair color, jersey number. Right? If I see your jersey number, I'm like, there goes 57 down the sideline. It's got the, I can't see your name. But if I see your jersey number, I'm going to reference you as that. That's your name to me now. Right? Or Social Security numbers are supposed to, see, 1984 is supposed to all be numbers. Right? We're not quite there yet. Right? But it's just a way of referencing somebody. Right? Nominal data. Now, you got to be a little careful. The second level is still nominal, but it just adds a level of being able to do something with the data. The next level is called ordinal. Ordinal data. And what do you think the root word of that references? Order, exactly. So you can actually put this data, it has not just that you can put it. I can put hair color in alphabetical order. Does it have to be in alphabetical order? No. So this is this is an inherent order. It must be in this order or else it doesn't make sense. Right? So there's some kind of inherent order. Alphabetical is not inherent, it's something that humans do, right? To pass the time, I guess.
So what would be an example of ordinal?
Put the rocks away. Oh.
What would be an example?
Yeah, good. What the hell would be an example of ordinal? You go to a restaurant. What's on some of the tables of some restaurants? These little cards that ask you to do what? Rate their service, right? So if you saw a little card and it said, rate our service, was it good, poor, excellent, or fair? You're like, dude, what the hell? Work on your freaking what? Is that in the right order? Or when you do student evaluations, what circles are you filling in? It's from strongly disagree up to strongly agree. So if somebody said, it's disagree, or strongly agree, or strongly disagree, or undecided, you're like, what the hell are you trying to do to me? No, put it in order. Does that make sense? So it's non-numerical data, but it still has an inherent order that it must be in to make sense. Do you guys see that? So it's a good question. You're like, what the hell would that be? But now you see them. Cool. All right. I love the look on some of your faces. Third level. Now we're getting into these roughly are like qualitative. This isn't perfect. There is some overlap, but this is roughly like qualitative data. So these are going to be roughly like quantitative data. So the third level is called, I just left my brain, interval. interval data, what's an interval from math? What's an interval from math mean? When have you seen the word interval in mathematics? A period of time or something, right? So if there's a period of time, there's a certain beginning and ending, and you can tell me how long that period of time was, right? So if I said my stopwatch, looking at it, it's 20 seconds right now, and then I wait, and now it's 30 seconds, how long was that period of time? From 20 to 30 seconds? It was 10 seconds. Good. So what operation did you apply? Subtraction. So this is data that subtraction makes sense. So now we're starting to do, now I know it's quantitative, because remember, what was the thing about quantitative? It was numbers that I can actually do math with, right? So I can't subtract people's jersey numbers and have it make any sense, but I can certainly subtract some other things. So here's subtraction. Not only can you do it, but it makes sense. Because I can subtract 2 zip codes all day long. Would the answer make any physical sense? No, right? You can go, oh, that's the thing. No, it's just a coincidence. It doesn't actually mean something, right? Subtraction makes sense. Let me put up here the next level, because that'll help us determine what the hell exactly should go in here. So if this is subtraction makes sense, you're not going to quite get this right maybe, but what do you think the next one would be? The highest level? Division makes sense. I like it. Right? It's harder to have division make sense than it is to have subtraction make sense. If you think about it. So this would be called, amazingly enough, what do you call a number that you can put one on top of the other one? Not a fraction, but it's a ratio. So this is called ratio level. Because that's where division makes sense. Gotta love it when the name actually tells you what the hell it is. So something that goes here would be truly numerical data that you can subtract and have it make sense, but you can't divide and have it make sense. What would that be? Like, I don't know, man. You're the teacher, right? Shit. I'll give you one. What year were you born? Somebody tell me. What year were you born?
91.
91? I love that. God, I never felt so... All right, so... what year was I born? What do you think? I don't want you to answer that question.
74.
That's really close. So I was born in 72. I am that old. Actually, I like the age. I'm 42, which is the answer, of course, to life years and everything. So I like that age. So why would year of birth be interval but not ratio? If I subtract 91 minus 72, it tells you what physically? How much older I am, right? All right, good. So the subtraction makes sense. You understand? Not just can you do it, but does it make sense? Does it mean something? So this one example would be year of birth, year of whatever, fill in the blank, right? So years basically are interval data. But what if I divide 1991 divided by 1972? Do you get a number? You get a number, yes, you do. Does it mean a damn thing? No, it doesn't mean a damn thing, right? So that would not be ratio. It is only interval. How we done so far? But notice, everything here is also one of these, is also one of these. It's just that you always, your answer to this question, what level of data is it, is always the highest level. Aren't years, don't they have a natural order? Yes, we didn't go, it was 2014, let's go to 2016 and just get this presidential shit out of the way. Everybody feels like it's already there anyway. Right? We can't do that. We got to go through 2015 first. So it kind of builds on itself. Don't just say to me, oh, it's both of these. No, that's the highest. That's the answer, right? Whatever the highest one. So what would be ratio data? Now be careful. The data has to be divided to make sense. Not just you made a ratio out of something, but the data itself could be divided and then it would make sense. So this is actually any measurement. If your backpack weighs 4.5 pounds and your backpack weighs 9 pounds, you can subtract them and it makes sense, right? But you can do more. If you divide them, 9 divided by 4.5 is 2. And what does that mean? Your backpack is twice as heavy. It has physical meaning. Do you guys see what I'm saying? So any measurement is basically ratio, except for something interesting. How many, most measurements fit in there, most measurements. How many temperature scales do you guys know? 5, tell me.
I can't remember names, but you got Kelvin, Celsius, Fahrenheit, and all that. There's one that's used specifically for gases.
Good.
It starts with an R. I can't remember.
Good. I'm always waiting for somebody to say something. But yeah, there's 3 main ones that people normally have heard a little bit about, and then there's some other more obscure ones. But the 3 main ones, there's 2 main ones, obviously, right? There's Celsius and Fahrenheit. Fahrenheit, of course, makes more sense. Not. And then you've got Kelvin, which not everybody has heard about. Right? Kelvin just sounds like some rich kid. Kelvin down the street. Kelvin is the one where if you ever got to 0 Kelvin, you are dead. There's no energy. But if you get to 0 Celsius or 0 Fahrenheit, does that really mean what it's supposed to mean? It doesn't mean 0. It means it's just a point on the scale. Are you with me? So another thing about ratio is not just that division makes sense, but also that 0 means what it's supposed to mean. And there's an inherent 0. So notice something about years. Years were not ratio. What does 0 mean in terms of years? Is that the beginning of time? No, because then you can go to BC, right? You can go to time before 0. There was time. 0 is not the beginning of time. So the scale for years doesn't have 0 in the right place. That's why it's not ratio. Twice as hot as a 60-degree day is not a 120-degree day. Do you agree with me? I don't have to get up to 120 to say, man, it's twice as hot as yesterday. Right? Or no? Do you guys not agree with me?
I agree.
You agree with me? All right. Smart man. I want you to agree that. Because it makes sense. If it was 0 degrees, what would make it twice as hot? 0 degrees? Because twice 0 is 0. You with me? So in order for division, which means multiplication has to make sense too, 0 must be in the right place. 0 must mean 0 of that thing. So Kelvin, actually, division makes sense. Kelvin is ratio because 0 means the absence of what I'm measuring. Right? Looks like it just blessed it. All right. So here, this would be Celsius in Fahrenheit, and this would be Kelvin. All right. Don't worry about Kelvin. I'm not going to bring Kelvin up too much because not everybody knows about Kelvin. Poor old Kelvin. Okay, cool. All right. So that's section 1.3. Let me throw a couple things out at you and see what you think about it. Ooh, I don't like that. All right, let me get something over here. Somebody's really teaching really hard over there. All right, here we go. Tell me which level of measurement this would be. The colors of M&Ms that you see in your bag. Nominal, right? I don't care if you like red M&Ms the best. There's no order to it, right? What about blood lead levels of low, medium, high, used to describe subjects who were exposed to toys from China? Blood lead levels, low, medium, high. Ordinal. There's an actual, obviously, an order to them. You kind of with me? So, I mean, those questions, they aren't overly crazy. Body temperatures in Fahrenheit, that's obviously going to be, Fahrenheit. Interval. So I got to remember, 0 doesn't mean what it's supposed to mean. So if I said the weight of a fish, the weight of fish that we caught, what would 0 mean? No fish. This is what the weight is measuring. How many, the amount of fish I have, right? So if I say 0, that's truly what it's supposed to mean, isn't it? Now, what about profit of a company? Could profit be negative? Yes, but is 0 in the right place? Does 0 mean what it's supposed to mean?
No.
Think about it. If I said 0 profit, that is 0 profit. You have not made any money. And if you made $2,000 last year and $4,000 this year, you made twice as much this year. It's ratio. You with me? So division does make sense because 0 is in the right place. Zero means the absence of profit. Negative means it's negative profit, right? So just because negatives exist doesn't mean that it's not ratio. You with me? Temperature is not ratio because zero doesn't mean what it's supposed to mean, the absence of temperature. No, it can get colder, so there must be some heat at zero. Okay, maybe. I don't want to get too deep into chemistry and physics. It's not the class we're in. Okay, so that's not too bad. I'll tell you what. Let me do a little bit of... I'll go back and do 1-2 now. We'll do 1-4 next time because it gets a little bit deeper into stuff. Actually, I'm going to do exactly the opposite of what I just said. I'm flip-flopping as I'm going through this. Let's do 1-4. That's actually a little more specific. This up here. For now. Shoot. I need to get a TA that just sits there and moves that thing around. All right. So I kind of hinted at this earlier. The types of sampling you can do. And the most common type of sampling would be if you had to pick some people to go investigate the cabin in the woods. What's one way you've seen in movies for them to pick? There's always that scene. What do? They have these bunch of matchsticks, and one of them is the longest. So it's sort of a random choice, right? Another way is to have a hat, and you put people's names in the hat, and you have somebody pick them out. You with me? There should be no bias. There should be no, well, his name's Frank, and you know the F gets stuck to the side of hats. It's not fair. Who are you? What are you talking about? All right, there's no paper or names are going to necessarily have any better chance to come out of the hat. You with me? That's really what random means. So be a truly random sample. By the way, this is section 1-4. This is types of sampling. So all the different types of sampling are always trying to attain truly random status. If it's not a truly random sample, so for example, I want to know how people feel about the movies that got the awards. And so I stand outside of a theater and I ask people as they come outside what they think. Why is that not truly random? What's wrong with that type of sampling?
You're selecting what you're doing. You're picking where you went to the movies and you start asking people, so you try to select the location and who you ask.
So much wrong with that. I'm there at a certain time. The only people I'm going to talk to are people that actually like movies. Or have seen movies, or have experienced movies, right? There are people that don't like movies that still should be having a chance to give their opinion of something, right? So there's that. That one is called a convenience sample. It was easy for me. What do you think about it? What do you think about that? What do you think about that? Yeah, I'm done. Thank you. Right? So you stand outside the door right before class because you were supposed to collect your sample of people. Like, you, what do you think about it? What do you think about it? What do you think about it? All right. And what's wrong with that is, well, let's see. What is wrong with that? If you come into class, you were supposed to collect a sample of people, and you just pick people as you come to class. What could be wrong with that? Why would that not be a truly random sample? Let's say you're trying to get a sample of Grossmont students. Why would that not be a random sample? What's wrong with it?
You didn't include night class people?
I like it. It's getting there. It's getting there. You didn't include truly night class people, like after 6 maybe. I don't know what you consider night. We go till 10, whatever. Yeah. Well, on the way to class, you're just picking students you see. Yeah.
The buildings are set up by departments that could maybe throw things off.
Okay, yeah. You're if you're on this side versus the other side of the world, right? Of Grossmont, there's certain types of classes that are taught over there. English is taught over there. ESL, foreign languages, computer science actually is over there too, right? And over here you get the sciences and math and who knows what else. Maybe a little smidge of other stuff. You with me? So that's a good point. So you're not getting, there's something that you're kind of skirting around. What's fundamentally wrong with that kind of thing? To be truly random, if you want to represent all of Grossmont, then every Grossmont student don't have to show up in your sample, or else that wouldn't be a sample. That'd be the population, right? But they must all have a chance. That's the key. To be truly random. Every element in your population. Do you notice how I slowed down there? That's a good sign. It's a note. Every element in your population must have an equal chance to get into the sample. So to be truly random, every school with me use the word element. Could be a person, it could be a shoe, it could be a llama, right? Llama. Every element in the population has an equal chance to get into the sample. That's what it means to be truly random. So anything, including Gallup, but they have ways around this, anything that collects surveys through the phone, will it be random? Because not everybody in the U.S. has a phone. And then you get into online stuff, and then you get a whole slew of hurdles to jump. You got to have a computer. You got to have internet access. You got to have interest in the website to even know they have a poll up, right? You kind of with me? So would that be a random sample? Hell no. So if you ever see we did a little survey of our readers, well, that's nice for you. It doesn't mean shit, right? Don't even look at it. This doesn't mean a damn thing. It just represents the opinions of the people that actually went there. And very often, if you ever go to like Reddit, anybody ever heard of Reddit.com? Yeah. Yes. They'll actually post things about, hey, they're doing a survey over here. Let's all go over there and answer this damn thing. So it might be the reverse of what is represented by that website, which I kind of enjoy that they do. So that's kind of like the goal for every type of sampling is to be this. And almost every type of sampling falls short. Right? So it's our perfect state. We can never be perfect. So some of the types, I was talking earlier about the rows. I could either pick a person from each row, or I could pick entire rows at random. Right? Let me see, 1, 2, 3, 4, 5, 6. See, cool. So I can just roll a die. And if it comes up 4, I'll take the 4th row. Everybody in that row. You kind of with me? Those two are kind of similar in a way. They both start with breaking the... Let's say you're the population. So I want to pick a sample of you. One way to do it is to pick a person from every row. Right? That's one way to do it. Another way to do it would be to pick entire rows of people and not other rows. You kind of with me? So those are two types. One of those is called stratified. You guys doing okay? All right. Yes? Say again? Yeah, let me write it better. Let me see if I can do that. Not really, Jeff. I'm sorry. Stratified. S-T-R-A-T-I-F-I-E-D. Stratified. Not stratified. I don't know what that would be. Stratified, and the other one's called cluster. Which, you know, if you watch Daily Show, actually, there's a different ending to that word. But they both start with the same thing. They both start with let's make this. Well, it's 6 rows. That's not too bad. So they both start with breaking our population down. So into these 6 rows, for example, right? Alright, so they both have the first starting point. But the difference is stratified takes some from each. Notice how the first letter in stratified is S. And what does it do? It takes some from each. So stratified is all about some from each. So you take a couple there, maybe 3 from there, 1 from there, 2 from there, 3 from there, whatever. You kind of with me? Normally, you try to do it proportionally. Like if there's only 3 people in this row, but there were 12 people in that row, I take a few more people there, so proportionally I'm taking the same percentage almost. You guys kind of with me? But you don't have to do that, but sometimes you do that. It's sort of like at a high school, you might want to get students to say something about how they feel about the rules that seniors get to do this and freshmen have to do that, whatever. Well, then you want to represent everybody proportionally. So you'll pick so many freshmen, so many sophomores, juniors. You with it? That kind of thing. So that's stratified. So your sample would be made up of all these people. Are you going to do every one, Jeff? No. All right. Throw those people you pick. So from this row, I would roll a die or something, and I pick a couple people randomly from that row. I pick a couple people randomly from this, every row. Cluster is sort of the other way around. Cluster takes all from some. So that's where I roll a die, it comes up 2. I'm going to take everybody in the second row. So I would take everybody from here. So my sample now is everybody from here, everybody from there, and everybody from there maybe. Right? So that would be a good way to do the percentage of people passing stats, because it's easy for a teacher to just, he's got the whole freaking class. It'd be much easier than me having to pick people at random. I'd rather just say, here was the results from my class. Does that make sense? And then it's easier for you because you don't have to talk to every teacher then. You just randomly pick several teachers and then have them give all this data to you. Does that make sense? So there are certain situations where it's easier to do that, Then you got to worry about, is it truly this then? Are these this? So if I'm picking people from each row, what is the test to see if it's random? If you're my population, what's the test to see if my method is random? Everyone has to have an equal chance. So if I pick several people out of each row randomly, does everybody have a chance? Yes. And I'm talking about people who are here today. So don't give me the, I didn't get here. People that are here today. Cluster, is that random? I always get people that argue with me on this, which I like. It's great, but you're wrong. If you argue with this, that is also has a chance to be random if it's done correctly. So does everybody have a chance? Well, then people say, well, if you pick that row, then I don't have a chance. No, if I've already picked, of course there are some I've left out. You can't think about it like that. Before I've picked anybody, does everybody have a chance? Yes, because then I roll a die, it could come up your row. You can't look at it after the fact and go, well, I wasn't picked. That's not random. No. What? You kind of with me? All right, good. So they both have a chance. Real quick story about this. I was teaching this class actually in an intercession when it was 3 units, which was insane. 3 weeks. And there was a student who had fought in Iraq. And he was really upset when I got to this point because he says cluster sampling is shit. You know, he's really upset. And I had to look into this. And actually what had happened was, not too long after they had taken over, a little while, they're trying to assess the how good the neighborhoods were in Iraq, and they did cluster sampling. But what they did was they picked areas. They broke Iraq up into areas, and they picked the areas that they knew were safe, because these were civilians going in doing this analysis. So they're not going to go over here where they know that there's stuff going on. Now, of course, their study was all about how safe were the neighborhoods. And so that was a blatant, I can't believe, when stuff like that happens, you're like, oh shit. Focus your attention on the mistakes that people made. It's not cluster sampling's fault. If you use it correctly, it's fine. But if you do something stupid like, was that random? No, they were picking it for specific. If I'm like, all right, I want to find out how you people think about my teaching so far. Everybody over here, I know you hate me, so I'm not going to pick you. All right, I'm going to get an accurate average of the way people feel about me? No, of course not, right? So it wasn't cluster's fault. That was very interesting to me because I was like, I got to look into this because he was telling me, and I'm like, I got to find out what the real story is. And there you go. Does that make sense? All right, cool. I like it. We've already talked about convenience sampling. So there's only one more type, believe it or not, and then we can head out a little bit early. All right, everybody's favorite phrase, including my own, actually. I'm the teacher. I get to tell me when I can go home. So there's convenience. We already talked a little bit about. And convenience, I'm not going to say a damn thing about because the definition is the word itself. Right? Normally it should be difficult. It doesn't mean that if it's not hard to do that it's bad. It just means that you would be convenient sample for me. But if I'm trying to say something about all stat students at Grossmont, you are a bad sample. You are a convenience sample. I didn't have to do any work to make it random. Therefore, more than likely is not random. Right? But the one we haven't talked about yet, its definition is sort of in its name also, systematic. So what do you think that means? What type of method of sampling would that be? Is she still going? Yay.
There's a system to it.
There's a system to it. It's crazy, man. So, for example, every 10 minutes you go out and take a temperature reading. Every 5 people, a cop, every 5th car takes does the speedometer thing on, sees how fast they're going. You with me? Just as a study, just to freak people out. There's a system to it. So again, I'm not going to really write anything down there. Every nth thing. So where would this be bad? Maybe I will write something. Every nth thing analyzed, or something like that. Or every nth minute, every nth song you hear, every whatever. You break it down into some kind of intervals. I don't want to use that word. But what could be bad with this? What could go wrong with this? And you're like, I just learned about it, man. I don't know. Yes?
Isn't it like when you're picking people, you want them in the same category of people?
Yeah. So, for example, here's a good application to systematic. The first person I pick is random, and then I pick every 5th one. Because you could argue, if I'm always picking you, then you don't have a chance. But if I say the first person is random, so out of this first row, I'm going to roll a die and pick that person, and then every 5th person after that, I'm going to pick you. Then is that random? Yes is the right answer, because then everybody has a chance. You don't go, well, you skipped me. Well, I might not have. So you had a chance, right? Does that make sense? All right. But where this could go wrong is if the thing you're analyzing has itself got some kind of like cyclic problem, like an assembly line. And in my head, I got the old cartoonish assembly lines. But you see this thing like ka-chunka, and then the next one comes down and ka-chunka, and the next one ka-chunka, and then the 4th guy goes, right? So the 4th guy is just screwing up. He's all broken. So if I pick every 4th item, I'm like, well, that's bad. And that's bad. Shit, everything's bad. Right? Or if I pick every 4th item, but I start at the good one, then it's going to look like everything's good. And I'm like, everything's good. Yay. So obviously you don't want to use this if there's something cyclic in your in the thing you're studying. Does that sort of make sense? I mean, it's a little further than we have to go, actually. But I just want to let you know there is a problem with this, that kind of thing. But this would be, like I like to talk about collecting, what was the problem I gave one time? Collecting eelgrass off the coast of Southern California every 50 feet. Collecting eelgrass to see how healthy our coastline is, or something like that. Right? So that's another systematic thing, broken up somehow. All right, cool. Everybody's like, yes, we can go now. So if you need ad code, come up and see me. We'll probably meet here again Wednesday, but I'm hoping next Monday we'll be ready to go to a larger venue.